Hi there, my name is Pedro Halfin, and this video is part of my instructor application for the summer of 2026 at UBC Gearing Up. The following slide deck was taken from a presentation created by my colleagues and I at the Youth Venture Program at EWB UBC. The slide deck was designed for students between grades 4 and 7 and introduces a couple of engineering principles behind a catapult. Thank you for your time and consideration. Hello everyone. Thank you all for being here. My name is Pedro Halfin, and I'm here to introduce you in the catapult activity. But before we start, it should be acknowledged that our activity is taking place on the traditional, ancestral, and unceded territories of the Musqueam, Sillay, and Squamish First Nations. So, what is a catapult? Well, a catapult is essentially a mechanical device used to launch objects really far. And catapults are really interesting to me because throughout history, they have been used to damage really large infrastructure like castles and barriers and buildings by essentially throwing rocks at really high speeds at them. Catapults are also really interesting for engineers because they rely on concepts like potential energy and leverage, which are principles that we as engineers pretty much use every day. But what is potential energy? Well, potential energy is essentially energy stored, and there are many sources of potential energy. One of them is gravity. If you look at the first picture at the top, the skier, just by being uphill, actually holds a lot of potential energy. If the skier moves just a little bit forward, Earth's gravitational pull is going to pull him down, is going to accelerate him down, turning that potential energy into kinetic energy. What about electrical potential energy? Well, that'll be best depicted by batteries. These are a common example of electrical potential energy. Batteries hold voltage. Voltage creates current. Current can generate electricity that powers many of the devices that we use today. What about elastic or tensional potential energy? Well, that depends on a material's property, really. Let's look at the third picture where the person is drawing the bow. When you draw the bow, the string is stretched up or tensed, and as the string is trying to return to its stable position, it takes the arrow with it, therefore launching it really far. And a question for you guys: what do you believe would be is the type of potential energy that is the most closely related to a catapult? That's right, that would be the elastic or tensional potential energy.